All right, you guys, so I have a follow-up question to our last example that we just looked at in this section. So what if the problem would have asked us to find all of the solutions, all of the possible ones that would have made this scenario true, and they didn't give us a restriction between an interval? So in the previous problem that we did before, the interval that they gave us was 0 to 2 pi. So we only found the answers that fell in that interval. But what if we were no longer restricted to that interval? And what if they wanted to know all of the possible solutions? Well, we already found our two answers here, 1.28 and 2.85. Those were the two that fell between the interval between 0 and 2 pi. Now, because trig functions are periodic functions, every time you travel around the unit circle around its period again, you're going to come back to these same original answers that we had. So if they ask us for all the possible solutions, all we have to do is write an expression that writes these answers given the period of the function in question. Okay, so if I wanted to write all of the possible solutions that will occur every time we get to 1.28 on the unit circle, I would say 1.28 plus the period of the trig function. Well, the trig function that we were looking at in this problem is cotangent. So I have to remember what the period of cotangent is. And if you guys remember, it's pi. So I would say times pi n. That will give me every solution that falls in the same position as 1.28 on the unit circle every time I go around the period of that trig function. Okay. Now, the other answer would be 2.85 plus pi n. So all I have to do is add the period of the trig function in question to my answer. So now that these are written in expressions, they give me every single possible answer that I could have for this problem without being confined to an interval. Okay, so just keep that in mind. Once you find your answers, depending on whatever your trig function is, you're just going to add that period to your answer. And then we always put like this variable here, like n. That allows us some freedom. So regardless if I move positively or negatively on the unit circle, that n can be whatever value I allow it to be. So if I move positively, I would replace n with a positive number. If I move negatively around the unit circle, I would replace that n with a negative number. All right, cool.